This web of overhead lines, and a need to erect gantries above them, was the catalyst for a new, articulated road rail crane. Each contact wire has been carefully positioned. To slew them out of the way would be both time-consuming and expensive. The result is a unique vehicle. Access to railway lines is frequently difficult. It may even mean building a temporary road. So the crane has been designed to reach the site by rail. But access by rail can be difficult too, involving special routing and, sometimes, serious delays. The road rail system minimises this difficulty. Palfinger's PKR 750 crane was originally designed to be carried on rail. The crane has a telescopic jib. It extends and extends and extends and extends to its full length of 18 metres. And it is tested with a 4-ton load at Palfinger's works. The crane has a reverse knuckle joint between the lower boom and the telescopic upper boom. This allows the telescopic section to extend upwards from a position well outside the centre line of the track. A telescopic counterweight, accounting for half the weight of the crane, has been introduced to allow work to a train on the adjacent track. Otherwise, the adjacent track would severely limit the extension of the crane's stabilizers. Other modifications have been the introduction of a 12-ton winch and a hammerhead to keep large loads clear of the boom. The overall weight of the modified crane make it too heavy for a rigid vehicle, so the articulated concept has been introduced. The Volvo tug is fitted with a standard SRS road rail system, a single axle forward, and a driven bogie at the rear. A second driven bogie is fitted at the rear of the trailer. The track is mounted at a level crossing. The combination is reversed until the trailer bogie is central over the track. This bogie is lowered onto the track and lifts the trailer road wheels clear. Now the trailer bogie and the tug road wheels combine to pull the trailer over the track and reverse the tug until its own rear bogie is over the track. This central bogie is lowered, lifting the rear road wheels of the tug. There are now 2 driven bogies on the track, but the front of the tug is still on steered road wheels. The central driven bogie pulls the front of the tug into position over the track. The front rail axle is lowered and lifts the corresponding road wheels. Now the vehicle is fully mounted and can move to the worksite on the railway. In case no suitable crossing is available, the tug is fitted with lateral movement beams. These can be used in conjunction with the crane stabilizers to move the entire combination sideways, so that, if necessary, it can crab onto or off the track. Once in position for a lift, the stabilizers are deployed and the tug is disconnected from the trailer. The trailer is lifted clear of the track so that it is supported entirely by its stabilizers. Thus, the track is protected from eccentric loading. Power to the crane is provided by the tug through umbilical hydraulic pipes and electric cables. The crane will be used to remove an old signal gantry. The crane extends upwards round the overhead wires and supports the old gantry beam while it is cut from its pillars. The beam is lifted clear. And slewed and lowered. Now the tug can be reconnected to the trailer and the stabilizers retracted for travel back to the level crossing. The crane will leave the track as it mounted, but in reverse sequence. The front road wheels are lowered and the front rail axle is lifted clear. The central driven bogie pushes the tug off the track. The tug's rear road wheels are lowered the central bogie is lifted from the track. The tug road wheels and the trailer rear bogie combine to drive the trailer off the track. The trailer's rear road wheels are lowered. And the rear bogie is lifted